All right, 3.2, evaluating logarithms. So what is a logarithm? Let's just talk about that real quick. A logarithm is the exponent just rewritten in a way that we can work with. So here's the deal. Let's say we have something like 2 to the x equals 64. Well, there's no way for us to solve for x, right? I mean, if I would have had some other equation like, 2x equals 8, right? We can get x by itself, we can divide by 2, and we get x equals 4. But in this equation, when x is in the exponent, we don't have a way to solve for x. But with logarithms, we do. It lets us rewrite it as a logarithm. So what we're allowed to do then is we can say if we have some number to the x equals n, we can write it as log base of n equals x. So look, the base is what was being raised to the x, and that equaled this number. And then all we really do is we just switch where the x and the n are. See? The x and the n just switch, drop the base down, and put the log in front. Okay? That's how we rewrite it. And then a logarithm without a base, some logarithm is just written like this, that means that the base is 10. So we'll play with this a little bit and show you what I mean. But it's just a way of rewriting exponents so that we can work with the exponent. So let's practice just rewriting things a little bit. It says rewrite these exponential equations as logarithms. So let's go ahead and do that. First one, 2 cubed equals 8. Okay, so remember that if it's b to the x equals n, we just drop the base value down, the base being the number that's being raised to the exponent, put the log in front, and then all we have to do is just switch the x and the n. So this would be n equals x. See, by doing this, the variable that's in the exponent is now all by itself. So that's what the goal is here, is to get the exponent all by itself. So if I'm going to rewrite this one, it's going to be log. The base is 2, so I just drop the base, 2, switch the 3 and the 8. That's it. That's all there is to it. That's rewriting a exponent, an exponential equation as a logarithm. Let's try it again on this one. This one's it's got a little bit more going on here. So now let's write this. It's log. Here's the base, right? It's the number being raised to the exponent, so it's log base 10. And then I can just switch these two numbers. So this would be 1/100th. Put little parentheses there. This means log base 10 of 1/100th equals, and then the negative 2 would go over here. See? These two values just switch, and we write it as log base 10. Now, again, let's just point up here. Remember, if it is a 10 as a base, we call this a common log. And so this 10 does not need to be written there. We just can write it, or just drop it out entirely, because any log with a base of 10 is just a common log. So I could just write this as log 100 equals negative 2. I don't need the 10 there. Okay? So anytime there's not a 10 there, or there's not a value there, that just means that there's an imaginary 10. In the same way that, like, remember if we was to write 1 times x, we don't really need the 1 there, right? The 1 is implied. And so in the same way, the 10 is implied there. If there's nothing there, it's a 10. Just a rule about logarithms to remember. Okay, so here's another one. I want you guys to just practice rewriting it. So I want you guys to see if you could do it. Remember, the little conversion chart is up here. Log base b to the x equals n. Drop the base down in front of the log, and then switch the x and the n values. Switch sides. Okay, so I would go ahead and just pause the video, try this, and then check back and see if you read it correctly. Okay, so we just write the log, drop the base, which is 5, and then switch the 4 and the 25. All right, these things literally just kind of switch sides. Okay, so that's what we should get. Let's try another one. Now it says rewrite these logarithmic equations as exponentials. So this is the same idea, we're just going backwards now. So let's take a look. Rewrite it as exponentials. Well, okay, this is a common log, right? There's no 10 down here. So if I want, I could put a little 10 there, but that's what it means when there's no number of it down there. And so 10 is my base, so I'd write that first, and then I'm just going to switch the 3 and the 1,000. And there we go. And that's a true statement, right? 10 cubed equals 1,000. So that works. All right, let's try another one. Okay, again, I'm just going to write the base first. 32 is my base. And then I'm going to switch the 1/5. Sorry about my 1/5 there. Equals 2. So 32 to the 1/5 equals 2. And what does that 1/5 mean? Remember, that 1/5 is the same thing as saying 32 to the 5th root equals 2. And that's true. The 5th root of 32 is 2. So there we go. Okay, so one more here. We got log base 10. 1 over 10 equals -1. So they didn't really need to write the 10 there, but hey, they gave it to you. So go ahead and write this as an exponential equation. Just check and make sure you understand it. Okay, so here's what you should have had. 10 is your base, -1 is your exponent, and that equals 1/10. And that's true. 10 to the -1, remember, a negative power just means it goes on the bottom, so that's a true statement as well. All right, so we've practiced that a little bit. So now we're going to talk about evaluating logarithms, and I got 3 different methods for you. I just kind of came up with the names of these. The first one is the common sense method. That's for ones that are pretty easy, and you'll see why. This one is called make the base match the result, and then this one's make the result match the base. We'll talk about these two. For more complicated ones, we've got to use one of these methods. But let's go to the common sense one first. So when there's ones like this, what I like to do is just put a variable over here, like an x. Because I'm saying log base 7 of 49 equals something, so let's just say x is that something. And then let's go ahead and rewrite it in exponent form. I would put the base first, switch the x and the 49. And now I can just look at this and say, okay, 7 to what power equals 49? Well, I know that 7 squared equals 49. So therefore my x is 2, so therefore my solution is 2. That's what I mean by a common sense one. If you just rewrite it in exponent form, sometimes you can just kind of see what it is they're talking about. 7 squared has to equal 49, so the answer to this must be 2. This whole thing just equals 2. Okay. What about ones like this? This one says make the base match the result. So I'm going to do the same thing. I'm going to just put an x here. And I'm going to rewrite it. So this is 16 to the x power equals 2. Okay, so this is a little confusing. 16 what power equals 2? This doesn't look like it's going to work all that great. A couple things that I want to point out. This is really 2 to the power of 1, right? And this one says make the base match the result. So is there any way that I can make the base of 16 match this with a base of 2? So I want to make 16 with a base of 2. So let's think about this. 2 to the 1 is just 2. 2 to the 2 is 4. 2 to the 3rd is 8. And 2 to the 4th, well, that's 16. So I can literally replace this 16 with a 2 to the 4th. So let's just go ahead and do that. 2 to the 4th to the x equals 2 to the 1. Well, hey, when I have an exponent, 2 raised to another exponent, I just multiply. So this is like saying, and I'm going to just use one color now, 2 to the 4x equals 2 to the 1. All right. Well, if these two bases are the same, then doesn't that mean that these two exponents are the same? So once we have the bases match, we can just kind of drop them, and we could just say, well, that means that 4x must equal 1. And then we can solve for x in the traditional algebraic way, divide both sides by 4, divide by 4, and we get x equals 1/4. So I know this one was a little bit more involved, but we got what x equals. So we've evaluated this logarithm. It just equals 1/4. And the more you do these, the more you'll be familiar with all these concepts. It's just pretty, it gets pretty intuitive, but you just got to put a lot of practice into it. So that's 1/4. Okay. On this one, it says make the result match the base. So now we're doing the opposite. Remember, this time I made the base match the result. So there's the base 16. I turned it into a 2 because my result was a 2. But this one I'm going to make the result match the base. So I'll show you what I mean. So once again, I'm just going to put an x here. Then I'm going to rewrite it as an exponent. So this is like saying 3 to the x equals 1 over 27. Okay, so I want to make the result match the base, right? Make the result match the base. So I want to make this look like that. Well, how can I write this in terms of 3? Well, first, let's just start saying, well, 3 to the 1, that's 3. 3 squared, that's 9. 3 cubed, that's 27. Okay, so we're on to something here. I could write this as 3 to the x equals 1 over 3 cubed. Okay. Well, one more thing I could do, because this doesn't match completely yet. I got it down to 3's, or base of 3's, but I still have it underneath a 1. But if I remember my property of exponents, if it's down there on the bottom, that's the same thing as saying 3 to the negative 3. So over here I have 3x equals 3 to the negative 3. Well, once my bases are exactly the same on both sides of the equation, then that means that my exponents are exactly the same. So I could just say x equals negative 3, and I'm done. Okay, so we got 3 different methods for solving, and I want you to practice these 3 skills, okay? So I have the common sense method, make the base match the result, make the result match the base. So I have 3 ones that I want you to try to do all those same things, and then we're going to come back to the video and I'll show you how to do them. So I want you to just try them all first. Remember, set it equal to a variable, rewrite it as an exponent, and then either make the base match the result match the base, or just use the common sense approach of, hey, this to what power equals my result. Okay? So go ahead and give that a try, and you're going to want to pause the video and then come back in a few minutes. Okay, so hopefully you tried all these problems so that you can make sure you're doing it right. Let's talk about them one at a time. I rewrote this as an exponent form, so that means 5 to the x equals 125. And then I just said, well, 5 to what power equals 125? And I just tested a couple, and I got that 5 cubed equals 125. Therefore, this must be 3. This whole thing must evaluate to 3. Okay, what about this thing? Well, I wrote it as an exponent, so this would be 1/25 to the x equals 5. And it's really 5 to the 1, so I'm trying to get the base to match the result, so I'm trying to get 125 to be in terms of 5. Well, I just learned that 5 cubed on the last problem, right? We just said 5 cubed equals 125. So I can replace that. I can replace that 125 with a 5 cubed. And once I do that, I have a power to a power, so that means I can just multiply. So that's like 5 to the 3x equals 5 to the 1. So that means I could just say 3x equals 1, divide both sides by 3, and I get x equals 1/3. Okay. Let's go on to the next one. It says 2 to the x equals 1/16, right? Because I'm going to put the base down, switch the x over here as my variable, switch this as 1/16. And now I'm trying to get the result to match the base. Well, I know that 16, 2 to the 3rd is 8, and 2 to the 4th is 16, so I know that I can replace 16 with 2 to the 4th. And when it's 1 over something, that means I could just change the exponent to a negative, so I can actually write this as 2 to the x equals 2 to the negative 4th. Well, once the bases match, that means the exponents must match, so this just means that x equals negative 4. Okay, so fun stuff there. A little bit of a typo in the title here spilled over, but I want you guys to take a look at this challenge problem. It says log 64 equals 1 to the 4th. I want you guys to try it. So if you want full credit for these notes, you're going to have to just try this problem. Start with just rewriting it like I did. Make this an x and just try to rewrite it, and then see if you can work with it and get it to work. You're going to have to make the base and the result both match. So there's a little bit of work that you're going to have to do, but have some fun with it. Should be a good challenging problem. Alright, see you guys in the next video.